Hambini fans, and welcome to another episode of the Shit and Sarcasm Show with yours truly. Let me begin the recording. Right. This one, the one that you've all been waiting for, the Absolute Black Hollow Cage Engineering Analysis by Hambini, age 5. First of all, a disclaimer. I am 5, don't believe anything I say. Is the pen working? Pen is working! Right, bit of background. So, this all started a few months ago when me, that's me on the left, and this pretty boy, him on the right, he's called Pete Talk, did a little discussion chat about various bits and pieces, and a topic that came up was these Absolute Black Hollow Cage rear pulleys. So if you're looking at a bike, what we're referring to is this bit here. We've got one here, and that's attached to one of these. And this new one that came along was $700. Now, Absolute Black got a bit shirty about all of this, and they said a few things, but anyway, here's an overview of what they said. They said they claim to be engineered in England and made somewhere in one of 27 EU countries. They said that. Apparently 50 employees with offices in several countries, many virtual offices, transactions via Andorra and Poland. And it is $700. Right, bit more. They had my last video removed in the UK, so if you are in the UK, you can't watch it on YouTube. They also call me an armchair engineer. They also call Pete Talk an armchair engineer. In fact, I think they call both of us armchair engineers. They dissed my hair and my hairdresser, and they've had lots of comments removed and blocked on Facebook, YouTube, Instagram, and a few other bits and pieces. You may or may not know this, they used my bearing video, which was the ceramic versus steel video, as part of their marketing. They put it on their Instagram page without my permission, which I thought was nice of them. And they claim to have lots of technical analysis carried out by an undisclosed Portuguese university. Right, time for a teardown. So this is the Absolute Black Hollow Cage that Grant from GC Performance sent me, and this is the box that it came in, and this is the stuff on the back. So it mentions that well, the grammar is quite poor, but the cage is compatible up to a 32 tooth cassette, might require an extra 2 or 4 links, designed in UK, manufactured in EU. It's almost like they're ashamed to say it was made in Poland, although I have some suspicions to suggest that this possibly wasn't made entirely in the EU. Made from AL7075, so that's a form of aluminium, carbon fibre polymer matrix, read that as plastic, rubber, ceramics, low impact packaging. And then there's this small disclaimer statement on the bottom. Any small aesthetic imperfections is due, I think that should be are due, to the handmade manufacturing and contributes to exalt the handcrafted nature. Now, when you open it up, the exalted handcrafted nature looks almost like injection molded item. It doesn't look particularly handmade. The other stuff that came in the box is obviously that, this tool to take the cages in and out, these 2 square section O-rings, which they claim are Silenex X pulley rings. This, I'm not sure what Grant did, he put that in the box. And some sort of sticker that if you want to actually put it on your bike and not feel like a plonker, then you can put this on your bike. There's a load of blurbage up here as well. So we've got Silent X-ring pulley, exceptional shifting precision, lower spring tension settings, reduced rotational mass and aero drag, 2 bespoke full ceramic bearings, dimpled aerodynamic surface, and revolutionary monoplate carbon cage with a patent pending. Now, Absolute Black also sent me this. This is the exact note they sent me. It says, "Dear Hambini, here is our bearing so you don't have to unglue it from the pulley and cause a potential damage." Okay, not sure about the grammar there, but there we go. "Also keep in mind, we don't claim that savings are on the bearings in our product, brackets, which we made very clear on our website from the beginning. Savings come from other aspects of the design." You'll note that there's no sort of address as to where this came from. It could have come from anywhere. So this is what they sent. This. Now, when I traced it back through DHL, it went back to Borut Fonda in Slovenia. So he sent this, and he also, I contacted him on Instagram. And he was quite keen to point out that, first of all, he wasn't an engineer, and he was also commenting about the bearing friction being low. So I think he knows, being a low part of the complete factor, so I think he knows that these bearings may not be as good as they may lead you to believe. Now, Borut, I don't think he's an Absolute Black employee, but he's some sort of contract kind of company. I did ask him, the pertinent question is, which Portuguese university did the research for them, and he didn't know, which makes me think, well, it makes me think a few things. It should make you think a few things too. Now, to make sure that this test wasn't a fluke and that Grant wasn't supplied with something that was, you know, a review special, I also got ordered one specifically that isn't a Grant special. So, this is what arrived. Now, we've got another hollow cage unit. Now, it looks like this is split. Now, when it arrived, there was no seal on there. That is how it turned up. You can see the other Absolute Black one is here, and it has their sticker on it. It's the same shape, but that one was already split. I wonder if it was a return. Call me a cynic. Maybe it was a return. And that's what you get in there. So that is, you know, as per how it comes. So that's all that. It looks pretty much the same. This one hasn't been used. You can see the tension marks are completely clear. Now, if we go back to this is this graphene lube. Now, one of the things that you have to do if you sell these kind of items in the EU is you need to provide a safety data sheet. And they don't have one. I contacted them for one, and they haven't sent me it. There's also a little message on the back from Marcin, founder of Absolute Black. "Your satisfaction from our product means everything to us." I'm sure it does. So here is the Absolute Black OSPW on the right, and a Dura-Ace. This one's actually a 9000. I only got this because I actually had problems with this one, which will all come apparent shortly. But it's just to give you an illustration of what they're like. So, I mean, if you look at the frontal area difference between the two, this one is considerably bigger than this one. Despite that, if you read Absolute Black's data, they claim that this one's minus 3.9 watts and this one is minus 4.1 watts. So you're getting on for about, well, what, 5%, 10% difference? So this one apparently, allegedly, is more aerodynamic. Now, with the aerodynamics out the way, let's weigh them. So this one's the Dura-Ace, and the Dura-Ace comes in at 43 grams. I appreciate it's a 9000 series, but you know, it's of the same ilk. This one is 70 grams, so the Absolute Black is getting on towards 50% heavier. Now, this isn't particularly scientific, but this is a Dura-Ace one. Let's give it a spin. Spin's happy as Larry. Okay, it's a bit noisy, but you can see this one's been used. But, you know, on the whole, spins fairly easily. This is the Absolute Black OSPW, so this one is the one that Grant sent. I mean, it is quite noisy. I won't pass judgment on why that is just yet. Now, this lower pulley, I think if I counted the number of teeth correctly, is 18 teeth. That bearing feels rough. And this upper pulley is 12 tooth. The Shimano Dura-Ace has 11 teeth, both top and bottom. That isn't the only difference. The other big difference is in the teeth themselves. So if you look at the teeth on the Dura-Ace, I'm just trying to line it up so you can get a decent view. These ones are incredibly deep. The Dura-Ace ones, like Shimano ones in general, are quite shallow. Now, the Dura-Ace one is predominantly aluminium. There's a bit of steel in there, basically where the fixings are. So these things are steel fasteners. The bearings in there are, I think they're probably C3 clearance. This body is aluminium, and then you've got a steel fastener on here to hold it in. The Absolute Black is, this is aluminium here. We've got basically plastic all the way around the rest of it. There's some rubber in the sense that these square section O-rings, which is the Silonex pulley dampening noise. So that is a square section O-ring. So there's your rubber, and the bearings are behind here. Now, this has been injection molded. You can see the injection molding marks all over it. So the molding marks, there's one there. If I get a little torch, maybe this will all turn out to be bad. I don't know if that's actually better or worse, but there's injection molding marks all over it. And, well, it is basically just plastic. Now, this thing, I mean, in his little note, Bora suggested the bearings were glued in. And there is quite a lot of movement on here. If you look carefully, you should be able to just about see a white mark, which is the edge of the bearing, and you can move that quite considerably on there. Now I thought, well, is that a fluke, or is it meant to do that or not? Well, this is the one from GC Performance. So you can see the mark there where the spring's been. That's the one I've used as well. This one is the one from them directly, same deal. So there's a bit of play in there. So using this tool, we can undo this and get the bearing out at the top. So that's the machine cap that's been anodized. And that's the bearing out. So this fit here is a clearance fit. This fit into here, now if I was designing it, I would have used a interference fit, but they haven't. They've just used well, it's a clearance fit, it's version push fit kind of thing. Well, the glue. The glue, we'll come to the glue in a minute. So that's the bearing that's come out of it, and that is the top pulley. Just to give you an indication of how that fit is, with the bearing out, it's very, very loose. And into the pulley, it's also very loose. Now, if we give this a little flex, I'm not pushing particularly hard, but that is quite flexible. That's surprise. I didn't anticipate it being that flexible, but that is how flexible it is. I mean, crikey, that's a lot. I mean, just for comparison purposes, this is the Shimano one. I can't even bend that one. And that's because it's pinned on both, not pinned, but its framework is on both sides, whereas this is just on one side, so it's two cantilevered structures. So in order to gain the same level of stiffness as that, you basically have to make your intermediate pieces about 8 times thicker, 4 times thicker, assuming it's the same material. Now, it's not made from the same material, it's something else. Now, this is apparently carbon polymer matrix. Let's give it a scratch test and then see what it's like. feels like plastic to me. Shaves like plastic too. Feels like jerry rigged, doesn't it? So this is the friction on the lower bearing. So let's get this out now and have a look. So we use the same tool, just the other side of it. Well, it's the same side, but it's the different section. And just undo. And then out this comes. So this is the lower pulley and totally slack. Totally slack. Now, this bearing is supposed to be ceramic, or it's quoted as ceramic, but it feels like plastic to me. So if I get the knife out, and give it a good scratch. So it's about 58mm. If you want it to be completely accurate, you shouldn't really use a vernier, but I'm just going to use this just to show you physically how much this is deflecting. So if I go and give this I'm just going to let off the vernier there and squeeze it. Oh, it's getting on for a millimetre. And you can see it's cleared there. Ooh. I'm going to do that again. So 58.01, squeeze. Now if I just talk about the lower pulley for starters, I'm not going to repeat myself for the other pulley. The hole, unsurprisingly, is slack. 58.16 on a 58mm bearing. The hole limit for retaining compound to work is basically 0.1. So 58.13, so that bit is almost within spec for retaining compound, but not quite. Now the hole here is elliptical. Now if you have an elliptical hole, what happens is the noise and vibration increase quite dramatically, and as a result the friction that you get in there also increases. Right, time to cut through this allegedly rock hard bearing. Oh, that wasn't too difficult, was it? Now, if this was genuinely ceramic, I'm not sure I'd be able to do that. Do you? Now, inside, we've also got this, which is the cage. Really, really strong, that. And then there's the outer race. Again, it feels like plastic. It bends like plastic. I wonder if it's plastic. Oh, would I be able to do that with ceramic? I'm not sure. So now we come on to the little subject of what this means. It says 2 bespoke full ceramic bearings. Now, I take that to mean the whole thing is ceramic, as in the sense like this, which is got 2 bearings. That is a steel bearing. It has steel inner outer and a steel cage. This is a steel bearing with a brass cage, and that you would actually call that steel bearing with a brass cage. So, you know, significantly more detailed. And that implies that it is completely ceramic, but I don't believe it is. But we're going to try it on here with a bit of flame. So this is the hollow cage unit. We'll take that off. And we've got the bearings. And then I'll push that out. There's a slack anyway. Right, so we'll give this a blowtorch in. If this is truly ceramic, nothing should melt. So if you look at the cage, all disintegrated. Balls are loose in there. Right, this is the Absolute Black test rig. So this here is the chain ring. Over here we have the cassette, and over here is the ceramic speed, in this case, jockey wheel. Now, if what we're doing here on this bit round here, this schematic diagram, is looking at this setup from above. So this drive motor is here. The input torque sensor, technically you should say transducer, is here. There's a chainring there, cassette, which I've already mentioned. And then you can't see it, but behind it there's an output torque sensor, which is where that cable goes. And then you've got your load onto the end of there. Right, let me play an overview of the Absolute Black test rig. So this is Dr. Borat, and he's just about to talk about the Absolute Black test rig. So this is what we've got. You've got the two torque sensors. They're made by a company called Sensor Technology, based in the UK. Coupling there, coupling there, coupling there, coupling there, and then the drivetrain is on the right hand side. Now what I want to draw attention to is, so this red box is that sensor. Let's just turn the pen back on. Right, it is an SGR 521 DDP, and the scale on it is, I think, 15 Newton meters. There's a 1, I'm not sure what the number afterwards is, but it's 15. Now, Absolute Black said this. So they said, we have spent a lot of time on this design and have one, if not only, extremely precise machine, allowing us to measure friction losses in the drivetrain in every gear combination. The machine has been built for the purpose only by a specialist company. We've already posted a video on our site with our machine in action, briefly presenting the power friction losses that these different setups produce, blah, 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 blah. Right. What I'm going to show you now is the data sheet for that. So that SGR 521 DDP is this. Now, if you look at the accuracy of this, it is plus or minus 0.1% of the full scale. Now, in the case of this Absolute Black sensor or transducer, I think it's 15 Newton meters, the range. It might be a bit higher. If it is higher, it's actually worse. Now, if you plug that number in, you'll get this, which is 0.015, right? Equated to power, through power equals torque times angular speed, you get plus or minus 0.66 watts. So that's how accurate that sensor is, okay? Now you've actually got two sensors. So you've got the input torque sensor, which is here, and you've got the output torque sensor, which is here, and both of these will have an error. So a conservative total error is plus or minus 0.71 watts. Now the reason why this one is lower is because it's spinning at a lower speed, so the error is slightly lower. Right, let me show you the install manual. This is the install manual, and for the transducer that we have, or they have, they're supposed to install a flexible strap, but they didn't. It was rigid. So I don't know why they've done that, but anyway, it can actually give you a rogue reading if you read all the verbiage in here. So anyway, it might be by the by, but there we go. Right, but this is where it gets a bit more important. So this is the graph that Absolute Black put on their the video. So you've got ceramic speed in the grey and the hollow cage black. Obviously the hollow cage is less. They've even gone so far as to put in the error bars, which are here. Now the bit I can't believe is, I honestly cannot believe they've done this, is those error bars. Those error bars are piddly small. They must be like 0.01 watts. That is the calculated error based on those two sensors. So the claim they've said is there's 2.2% less friction than ceramic speed. So if you do that, 2.2% of 6 watts, let's take this one, gives you a torque of 0.003 Newton meters. That is a ridiculously small torque, very, very small. I went around asking various people I know, can
can you measure that torque? And basically you'd need 150, 200 grams worth of gear to be able to measure that torque. The sensor accuracy is 0.015. So what they're saying is, roundabout way, is they've said there's 0.132 watts of difference, but their sensor can only read that accurate. Now, I don't know. I honestly don't know what they're thinking. I honestly do not know what they're thinking, because that is, I just don't know. I mean, for the engineers out there who will be in the comments box, that is serious. That's not even mediocre. So you've got, if we put it into, things that you could sort of explain, let's say we've got Usain Bolt and another sprinter, and Usain Bolt runs it in 9.8 seconds to 100 meters. Joe Bloggs runs it in 9.6, but your stopwatch will only measure to the nearest second. That's what they're saying. So the rest of it is just an estimate, and that's from their stuff, not mine. Right. So how did I do it? Well, I didn't go for an expensive option because I couldn't. And the other thing is, with the Absolute Black setup, if this is the graph of torque versus time, it looks like that. It's horizontal. It's just a constant torque. In reality, when you pedal, it tends to look more like that. And that peak torque, sorry to excuse the pun, can be a lot higher than the average torque. So I went for me pedaling, power meter, and then set the turbo up at 220 watts in ERG mode. And then this is the results that I got. Now you can see we've got Dura-Ace OEM, so that's with the OEM bearings in, which is that one. Dura-Ace with NTN, so I just retrofitted some NTNs in there. And then we've got the Absolute Black. Now, the error bars on here, I've put them on. You might say, well, why is there such a wide error bar? Well, if you do the maths, that is how big the error bar is. Now, if you look, you'd say the Absolute Black was slightly higher than the other two, but it's not significant enough to be able to say there's a significant difference. It's not high enough based on the error bars. So, always take that into mind. Right. Absolute Black's explanation of the bearing performance. Let's play that.
The ask from our client is, why our pulley wheels don't spin as well as the one from our competition? Well, the reason is very simple. We designed them not to.
Right. Earlier on, I said, well, I thought the bearings felt like plastic, and they do honestly feel different. I mean, I've had lots of ceramic sleeves and things in the past, and it doesn't feel like that. It's a lot more flexible. I wonder if something has been added to it to make it more pliable. I don't know. The other thing is the surface finish on it is quite rough. So you can hear that. It's quite soft. Like here, you can see I've scratched it with a file. So that's that. I wouldn't expect a really, really hard bearing to be able to do that. The cage is PEEK or plastic or PTFE or something like that. Now on the box, the Absolute Black box, it doesn't list that. It just says made from AL7075 carbon fibre polymer matrix rubber ceramics. It doesn't list PEEK, PTFE or plastic. So there we go. That's the bearings are claimed to be fully ceramic. Well, they're not, because they're the seals and the cage is plastic. I think it's PEEK. And it's got very high rolling friction. Now the bearing seals are here. Now these things are supposed to be non-contact, but they are a contact, and they're clearly not ceramic because I've bent one. And ceramic definitely isn't going to do that. So there you go. The kind of seals that you get in normal bearings are this. So they're metal and rubber together. So they give you a good sealing performance. This, which is, it almost feels like cardboard. After your first run, you have to bin it because you can't put it back in. It just will not go back in. Right, bearing vibration. So this is normalised. So you've got the blue line, which is absolute black, and the red line, which is NTN. So you can see there's a considerable difference there, and you've got all these fault frequencies. So they're indicative of usually a bearing that has been run for a long time. But in this case, they haven't. So, you know, there we go. That's a contributing factor, I think, to the increased friction. You've also got the bearing seat. So this is the lower bearing. It's 58 mil. You can see it's not round. Another thing is you've got very, very deep teeth, and I mentioned it in the teardown. They are extremely deep, and when they mesh in, you've got an additional friction load in there. Now I think they've done it to aid the shifting, but that plus then the bearing O-ring, the O-ring friction on the chain makes it higher than it should be. Right, Grafen lube. Grafen lube. Now this stuff is technically an industrial lubricant. And it comes under REACH legislation. So REACH legislation is where stuff that is, well, anything potentially hazardous should have a material safety data sheet, or they're just generally called safety data sheets now. Apparently, there is one, but Absolute Black's IT department messed up, and Samantha said she would fix it. There isn't one on the packaging. And there isn't one on their website, so let's just see their website. So if you go down and then go to safety sheet available here, click, there is absolutely nothing. If you go and search for let's say Muc-Off safety sheet. Yeah, there's the one for Muc-Off, so it gives you a load of things, environmental hazard, label things. It's just in case someone drinks it or you get it on your skin and then you need to go to hospital. If I do the same thing for Squirt, this is the one for Squirt, so that one is made in South Africa, but it's the same kind of thing. It you know, accidental release measures, how you do that, and that sort of stuff. Right, the final bit is this one. So the questions, right, I can't emphasize enough the claimed power saving that they have, 0.132 watts versus the ceramic speed, is smaller than the accuracy of their instruments. Now if I was ceramic speed, I'd be ringing them up to whinge, but that's, you know, if they've done that, you don't know what the rest is going to be like. The bearing friction is excessive. I mean, you can see that when you spin the bearing round. I mean, noise is just vibration that you can hear, and you can hear that. Bearing flexing or popping off its seat when it's laterally loaded. I mean, you can see that when we were doing the teardown. They are held in with glue. Don't know what to say about that one. Right, if you run this bearing with no seal, it is ill-advised. I wouldn't recommend you did that, because as soon as you get some particles inside, it will displace the inner and outer race. And then finally, distributors, they are buying this at €239. It might vary from one distributor to another, but I've seen an invoice where that is the price, and then from there it is sold to the customer at $700. Right, that is the end of this video. Please do comment down below, questions, all that kind of stuff. I don't really know what to say. I mean, from an engineering point of view, I'm gobsmacked, absolutely gobsmacked. It's just outrageous. Right, thanks very much, and until next time, keep banging your hairdresser.